Good afternoon, students. The condition outside is very bad. You are all aware of that, and do follow the instructions given by WHO and the central government of India. You'll be getting your notes on a timely basis. I'll be sharing with your CR, and I will also be giving in your group. So I have also decided to plan a series of video lectures so that it is easier for you to understand the concepts related to the subject of environmental engineering too. Okay, so I'll just briefly revise what topics were taught before so that you get a glimpse, and then you can proceed further topics into the subject. Okay, so we were studying the unit 3, that is wastewater characteristics. So topics that were covered till date is first topic is environmental conditions. So you are all aware of this. There are 3 types of environmental conditions: your aerobic, anaerobic, and your anoxic. Okay, so what is aerobic and environmental conditions? So it's the condition where there is availability of free oxygen. So in aerobic you have free oxygen. Okay, so that is called as aerobic environment. And anaerobic you have absence. Okay, it's total absence of free oxygen plus bound oxygen. Okay, what is bound oxygen? So bound oxygen is in the form of nitrates, sulfates. Okay, I think it's already covered. And the third is your anoxic. So what is anoxic? Anoxic is absence of free oxygen but presence of bound oxygen. Okay, of bound oxygen. So that is what your anoxic environment is. Okay, so after that we studied about the cycles of decomposition. Okay, so second topic that we studied is the cycles of decomposition. So under cycles of decomposition there are the 2 main cycles that we have studied. One is your aerobic oxidation or aerobic decomposition. Okay, so what are the benefits of aerobic oxidation? I know I hope you have all got your note yesterday about this. So just go through your note, you will understand. Just I will mention a few highlights of this. So end products of what things you have to remember. Most important is the end products of this type of decomposition are very stable and non-odorous. Okay, and non-odorous. Okay, all right. And obviously there is availability of free oxygen. So that is always there. Second is your anaerobic decomposition or putrefaction. What is putrefaction? Putrefaction is called as rotting. Okay, putrefaction is rotting. So obviously this is in absence of free oxygen. Okay, and end products are highly unstable. Okay, so this we have already learned, we have covered. And then we have studied about the physical parameters of wastewater. So physical parameters of wastewater we have studied. I have given you notes, you please refer to this. We have studied about the turbidity, okay, then odor, temperature, color, and total solids. So we have completed till this. Okay, so these things we have completed. So today we'll be starting with units of measurements. Okay, so what are units of measurements? So we'll be starting today with units of measurements. Units of measurements. Okay, so what are the units of measurements? Okay, so generally units of measurement, this is for physical and chemical parameters. So units of measurements is applicable for physical and chemical parameters. Chemical parameters. Okay, so we have completed our physical parameters. So we'll be starting chemical parameters today. But just before that, it's better to mention what are the units in which they are measured. Okay, so generally expressed in, so physical and chemical parameters, not all but most of the physical and chemical parameters are generally expressed in mg per liter, then parts per million ppm, parts per billion ppb, and microgram per liter. So in these four units generally the units of measurement means the chemical and physical parameters are measured. Okay, so one very important relation, so this is to note for you. Okay, very important relation is ppm. So our most important thing in the environmental engineering subject is we will mostly deal with mg per liter and ppm. Okay, so this, so that there is a relation between these two. So ppm is equals to mg per liter divided by specific gravity of the fluid. Specific gravity of fluid. Okay, so this is the relation. So ppm is equals to mg per liter divided by the specific gravity of the fluid. So in environmental engineering 2, which is mainly based on wastewater. Okay, so since it is based on wastewater, so wastewater is nothing but it's a liquid. Okay, so liquid is what? Liquid is water. So what's the specific gravity of water? If we express specific gravity of water, we know specific gravity of water is 1. Okay, so that we know. So hence for water and wastewater, for water and wastewater, 1 ppm equals to 1 mg per liter divided by specific gravity is 1. So therefore, okay, let me write with a different color. Okay, so that therefore for water or wastewater, 1 ppm equals to 1 mg per liter. Okay, so this is just for water. Okay, but since our focus is wastewater and in environmental engineering 2, so we will be using 1 ppm equals to 1 mg per liter. Okay, so now moving on to the next topic. So we'll be yes, so before starting I'll just want to mention that let sewer. Okay, I'll just briefly show you something about sewers. So you know sewers are underground conduits, you all know by now. Okay, underground conduits. Okay, so I'll draw a cross section of a sewer. Okay, okay, let's say we are looking into a circular sewer. Okay, so this is a circular sewer. Alright, now the most important parts of the sewer, you see this portion. Okay, this portion, the inner surface. Okay, this portion is called as the crown of the sewer. Crown of sewer. Okay, and this is the bottom part. Okay, this is the bottom part. So the bottom part is called as invert. Okay, invert of sewer. Okay, this is the most important terms: the crown of the sewer and the invert of the sewer. Okay, and this one, this will be your inner diameter. Okay, let's say this is small d, it's inner diameter, and this complete capital D is your outer diameter. Okay, so this is a sewer. Okay, so next, so now we'll be moving into your chemical characteristics. Okay, there are different chemical characteristics. Shortly I will explain. Okay, so chemical characteristics. Okay, so first is pH value. Okay, you know what is pH value. It gives the acidity and the alkalinity of a substance. Okay, so point wise you can note it down. Okay, so fresh sewage is generally alkaline. Fresh sewage is generally alkaline. Okay, generally pH value is between 7.3 to 7.5. Okay, as time passes pH value falls. Okay, pH value falls due to production of acids. How acids are produced? Production of acids by bacterial action. Okay, so bacteria is there in your wastewater, so by bacterial action they undergo some decomposition. So you have already studied about the types of decomposition. So by those decomposition acids are formed. Okay, and hence the pH value decreases. Okay, so but general value, okay, general value of a if you observe properly, okay, after oxidation means after decomposition is complete, it again becomes alkaline. So it again becomes alkaline. Okay, all right. Okay, so this is done. Second is our chloride content. So how much chloride is present? Okay, it's the most important, one of the most important physical characteristics. Just to show you, okay, how important is that. See, human excreta, for example, human excreta contains about 6 grams of chloride per person per day. So one person excretes 6 grams of chloride. Okay, so wastewater, yes, obviously the source of wastewater is our toilets. Okay, so think how much quantity of chloride will be present in the wastewater. So that is why this is very one of the most important physical chemical characteristic. Okay, so and hence there is a requirement for the determination of chloride also. Okay, so how chloride is coming into the wastewater? So chlorides in domestic wastewater, chlorides in domestic wastewater, chloride in domestic wastewater occurs due to, okay, just a moment, occurs due to kitchen waste, obviously because in kitchen salt is used. Okay, and some fruits and vegetables, they may have chloride in them, so obviously from kitchen it will come. Then human feces, okay, let me cut this, human excreta and urinary discharges, obviously from urine also chloride is getting into the wastewater. Okay, so okay, and why it is the second means it is important because of this. Okay, and it is also important to determine chloride because chloride interferes interferes with COD determination. So in the determination of COD, what is COD? So we'll be discussing COD in details in the coming chapters, in this unit only, in the coming topics. Okay, COD is chemical oxygen demand, chemical oxygen chemical oxygen demand. Okay, so chloride, we'll discuss this in detail, okay, in the coming topics. So chloride interferes with the determination of COD, so that is why you must have to look for the determination of chloride. So chloride determination, that is why it becomes essential. Okay, so how to determine chloride? So there are different methods for determination of chlorides. Okay, but the main important method that we'll be using, we'll discuss that only. So the determination of chloride. So we'll study about determination of chlorides. Okay, so how do you determine chloride? So there are different methods for determination of chlorides. Okay, you have Morse method, also called as argentometric method, okay, then you have Fazan's method, okay, and then you have some electrochemical methods also. Okay, so we'll be more focused into the Morse method or argentometric method. Argentometric, okay, because why this name? Because we'll be using something related to silver. Okay, that is why it is called as argentometric method. Okay, so what is in this method, what we do is that wait Okay. Okay, so Morse method is mostly used argentometric. Why argentometric? Because we are using silver. So silver is in Latin. Silver is called as argentum. Argentum. So that is why this method is called as argentometric method. Okay. So what is this method? So what we do? So this method is completely. So this is Morse method. Morse method of determination of chloride in a sample of wastewater. So what we do, there are some steps first. So this is completely titration. This method is based on the method of titration. Okay, so we'll be using titration. How to do titration? What we'll do, we'll take in burette we will take silver nitrate. So in burette we will be taking silver nitrate, and then in conical flask we'll be taking wastewater sample, wastewater plus potassium chromate. Okay, potassium chromate, which is yellow in color. Okay, so in burette we take silver nitrate, and in conical flask we'll be taking wastewater, and to this wastewater we will add 2 to 3 drops of potassium chromate, or till the color becomes yellow. Okay, so then what we do, we will titrate. Okay, after that we will titrate till which point? Till titrate, you will do titration till yellow color, okay, is converted to reddish brown. Okay, so we will do titration till yellow color is converted to reddish brown or brick red color. Okay, the chemistry part you no need to understand, because this is not a chemistry class, but most importantly is that the yellow color of the potassium dichromate is converted to reddish brown, okay, or sometimes called as brick red color. So this is the end point. Okay, so this is the end point of the titration. Okay, so what is Morse method? It is a method of titration to determine the presence of chloride in a sample of water or wastewater. So what in this method, what it is done, or how it is done? So we take a conical flask. Okay, so we take a conical flask, and in this conical flask we take wastewater sample, some known amount of wastewater sample, and then we add 2 to 3 drops of potassium chromate. Okay, and then this we titrate with silver nitrate. Okay, so we titrate with silver nitrate. So this is how we get, and the end point is from yellow to brick red color. Okay, so two things I want to tell you here. So whatever solution, okay, this is note for you, whatever solution you take in burette, okay, solution in burette is called as titrant. So concentration of this titrant, concentration of this solution is known, solution is known. So we have to know the concentration of this solution, okay. So that is called as titrant. So titrant we take in burette, and in conical flask, the solution that we take, means the solution whose concentration we want to find, is called as analyte or titrand. Analyte or titrand, unknown. So this is unknown concentration. So we want to find the chloride content of the analyte, okay. Analyte means the solution that we keep in conical flask and whose concentration is not known, okay. So in burette, in this Morse method, we are taking silver nitrate. Generally 0.0141 normal silver nitrate is taken, okay. General value, we can take more or we can take less also, that depends, but generally it is 0.0141 normality solution of silver nitrate is taken, okay. Okay, so we'll meet again with the third chemical characteristic, which is your nitrates, okay. So nitrate content,